Yeah, I cannot use it for Photoshop. It's only like,
Exactly.
so I to use it. So as soon as I see it, I leave it somewhere. Thank you.
Until 3:20 schedule, so we have leeway for 10 minutes.
You know.
So this is now we have this way of presenting, which is through the web. Did you see that? You don't have to look up on that. That's really, we asked for that. I'm telling you, I don't have.
I'm gonna start distributing because it's already 31.
So shall we start? Yeah. Hello, 6LO working group. So this is our IETF102-6LO session. We have 2 hours, and I'm Samita Chakrabarti, my co-chair Gabriel Montenegro. Our AD Suresh Krishnan, who is not here today, but Terry is representing Suresh. We have minute takers, Ryan Hu, thank you very much. And we are looking for another minute taker. Okay, Daniel, okay, Dominic, thank you very much. So maybe I should have just put your name already. And then Rahul Jadhav, who has volunteered for Jabber Scribe. Thank you, Rahul. And with that, we are going forward. So note well, if you are not familiar with it, please read the description. And if you have any disagreement, please then leave the room. Otherwise, this is our instruction directions from IETF. And today's agenda, we have full agenda for 2 hours, starting with the chair slides, and then we'll go with Pascal's presentation on RFC 6775 updates and related ND updates. And then there are several others presentation with BLE mesh, NFC updates, the 6LO applicability, and there are new drafts which are not working group document yet. Then we will address them, IPv6 for PLC. And then we have work coming out of the 6LO fragmentation recovery design team. Now we have 2 documents that are in this working group out of that investigation that we will discuss. And at the end, we will have a new proposal from Hudson Ayers and Phil Levis from Stanford University. And they have an interesting investigation on the low power nature of the devices and how that can affect the interoperability, and they have a proposed solution. So with that, we will start with the draft status. So for the draft status, RFC 6775 update has gone through long IESG review comments. Pascal has been diligently updating those and commenting, addressing the comments. So it's at the last stage and waiting for Suresh to give a okay. And then 6LO backbone router is prepared for working group last call. 6LO AP ND, which Pascal will present today, it's in work in progress. 6LO NFC, so it has completed working group last call, and it has got updates, and I have given my updates, my review comments as a shepherd of that document. So he has final updates, which will be ready for the ISG review pretty soon. 6LO BLE mesh, which is another working group document. Carles has been working on it, and now with implementations, it's in work in progress. And then 6LO applicability and use cases document. We will, that's also maybe ready for working group last call after this IETF. And then 6LO deadline time, it has completed last call, but no comments were received, as I heard from Charlie. If you have comments still, we have time in next 1 week or so, please provide comments. Otherwise, we will do Shepherd's review and submit for ISG. And then finally, design team concluded for fragmentation and reassembly at the last IETF. And we came out of 3 documents out of that. One of them is on the implementation, lightweight implementation from Karsten, which is being discussed at the LWIG, Lightweight Implementation Group. And the 2 other documents that are part of 6LO, which are minimal fragment, which Thomas will present remotely, and then we will have 6LO forwarding fragments. So any comments? Okay. Any comments with the agenda today? Okay, so.
Hi, Carrie Lynn. I just had a question about the last paper, and I assume there's been some discussion around whether it's more suitable here than it is in lightweight implementation guidance, or will it be presented in both places?
I know it's presented here, and after that we can discuss what we can do.
Yeah, but there were discussions. I'm not sure if on the list, but there were some discussions. Because that was one of the points that was raised, and it seems like maybe part of it belongs to Nelwick, but there might be some protocol elements. So that's why we have it here as well.
Okay, so Pascal is next. Let me. Yeah, we are. Oh, yeah, it should work. Hold on. Let me go to the slides.
So as Samita said, this is the final stage for the work on the RFC 6775 update. And can you please scroll it a bit because it doesn't seem right. Looks much better. Okay, so this is the usual unmet expectation. It has recently evolved a little bit because the initial expectation that 6LoWPAN-NG would enable to register for proxy services of our backbone with a backbone router has been extended to enabling whatever method for return routability, including proxy, but also routing protocols. So nothing much here. The family, it's a family of 3 working group documents. One of them is this, which is mostly complete. As Samita said, we've got the address protection, which is an extension to it to make it secure. And then the backbone router, which is a proxy operation of our backbone, if that is the method that is used for reverse routability. Okay, so the generic flow is still in a very complex network the way it was. Use 6LoWPAN-ND or C6775 update to register to a 6LR. The 6LR uses an extended DAR message to the 6LBR, which may inject that in a routing process or a proxy operation of our backbone, for instance. And now this is just an example because it might be that the 6LR is a Ripple router, for instance, or it might be that it's a Rift router, and the same exact operation works. So last IETF101, we were in the middle of the discussion from Dave Tharer's review, and there was this sentence that Dave wanted to change. Dave wanted basically that we write what network operators and administrators must do, which is provision enough resources in their network for things to work. And further reviews, which were covered in draft 18 by Warren and Bern, ended up changing that must again. So it went up and then it went down. So we came back to something like before, with Dave actually agreeing, that we just state the fact. We don't say it's an uppercase must, it's just a fact of life, that you have to provision enough resources in your network. So this is, last IETF I presented that we turned the text with this uppercase must, and now I present to you that the must goes away again. Miria indicated to us that the readability could be better if we just moved the structure a little bit around. So we also did that in draft 18 quite right after the IETF 18 was published. So we also added some clarification text about the fact that if the T flag, which is introduced in this spec to say that the TID is some value, if the T flag is not set, then the TID should be 0. That's implicit by inheritance from RSC 6775 because it's a reserved field, but we added text to say it. Then Benjamin came in, and from his review, the big thing that happened is mostly that we define much more correctly what the rover field is. So we ended up with this new definition that you can see here. And in the final document that we have now, 21, this text is not actually at the same place, because this was, after Benjamin's review, we placed all this text in the definition of what a rover is. And in fact, if you look at it, the first sentence is the definition of what it is, and the rest is how it's operated. So as part of Charlie's work and Charlie's review, we actually moved the second part somewhere else in the document. It's not lost. It's just moved more in the rover operation away from the rover definition. Right. And there was also discussion by Benjamin whether a non-zero status is an error. And yes, 6775 is very clear on that. So by inheritance, a non-zero status is an error unless new RFC says different. And finally, the last review was Eric. So actually, Eric had a lot of background question about maybe having more introduction text and things like that. So we added some some clarification on why we do it, things like that in the introduction. And then again, some of that text moved away, and that was again part of Charlie's review. And some of that text has fallen into the appendix section. So we didn't get a real feedback from Eric about whether that text was what you wanted, and if it's okay finally to have moved down into the appendix. Because the discussion with Eric moved to the APND draft quite rapidly, so it's probably the only ISG review for which I don't have a clear acceptation that we did the right thing. So it would be very nice that we contact Eric, if you guys or the ADs could just check with Eric that he's happy with the text as it is now. Apart from Eric, I think we are there. For all I understand, I'm pretty sure they're happy. Eric, I'm not too sure because we moved to the APND discussion and never came back to this and say, okay, I'm fine. You see, the kind of comments we got from Eric on this document was really, oh, why are you doing this? Right. So that's the sort of text which is now in appendix. But after Eric's review in 18, I put it in the intro. After Charlie's review, it went down into the appendix. And then we moved the discussion to APND, and that's what the discussion is still, but we don't have a clear acceptance of the changes that were made for him. Oh, and then there is this down reference thing for which I don't know what to do. Part of the ISG review told us that some references we had in the terminology, those two, should have been, that's Adrian, I think, should have been normative reference, because that's a terminology that we're using. And these are terminology documents. But the fact is, those two terminology documents are informational. So if we normatively reference informational documents, then we have a non-ref. So how do you do? How do the other do, right? I mean, what happens in normal document when you use terminology from an informational document? Is it an informational ref or is it a normative ref? So I made it a separate section right now. So the trick is I have three reference. I have normative, terminology, and informational or something like that. And I know as a shepherd that there is this rule of checking if there are only those two, normative and informational. And no, the answer is no. I have a third one, so I don't know what to do with it.
Terry Manderson, not speaking for Suresh, but the other INTERA AD. Downrefs are actually permissible in IETF documents. It just needs the responsible AD to say that it's okay to do.
Okay.
So it'll be a discussion you'll have to have with Suresh, so that that will then stop the breakup of the additional sections in the back matter.
Yeah, so
but talk with Suresh, okay?
Okay, so let's just do that. So the change is like a no-brainer, right? We just move that extra section back into the normative and we're all set. So what happened since the last ISG review? You saw the 3 versions were published. To my best knowledge, most of it is purely editorial, even if the changes are quite important. And that has a lot to do with Charlie working very hard on this document. So as part of this change, my French was turned into English. It's part of it. The consistency of the document was improved. Like when you have a section talking about something, then all the discussion about that something should be in that section, not in the definition or any place else. So that's part of what Charlie said, and that did. And as part of doing this, it caused some paragraphs which were introduced for ISG review to be actually split. Doesn't mean they went away, it just means they were split. I didn't find important text that went away, because Charlie also eliminated some duplications as part of this work. But I've not seen that this caused any change done for an ISG review to be undone. Right? It's just moved. And sometimes we worded it in proper English. Okay. Now, we had a number of discussions on the mailing list. One of the prime came in really triggered by the discussion with Eric on APND. It has to do with the fact that the rover field, which is how we protect the registration, can be all the way up to 256 bits. So it's no more constrained to the 64 bits of new I64 field. But this thing goes into a DARDAC message, meaning that now the DARDAC message can be of variable size. But the DAR does not have this rover thing as an option. It's an integral part of the message. Every time you send DARDAC, part of the message is this thing. So with the earlier version of the document, we just said, hey, look at the total size of the message, and now that tells you what is the size of the rover inside the DARDAC. But then came the need to extend DARDAC with options, and we can't. If the size tells us what the rover is, then we cannot have an option which changes the size. So we said, hey, we really need to signal the size of the rover in the DARDAC. And so we went scratching our heads on the mailing list and stuff. And we ended up indicating the size of the rover field as part of the ICMP code. That's the best place we found, because sometimes the rover itself can be a key, and you want alignment and stuff, so you can't steal bits from the key. So you end up having to signal it somewhere else, and there was not much space left. So we decided that the code suffix would be splitting the code would be the neatest thing to do. It's consistent with the way the doc was at the time we discussed it with Adrian Farrell, because we had one bit here, which was pretty much the T bit saying, oh, it's a DAR or an extended DAR. Now, instead of having one bit, it's those 4 bits which actually signal it, because we now signal, oh, it's an extended DAR plus the size of the rover. So it's not inconsistent with the way it was thought initially. We also, with Charlie, we went down through the history of ICMP codes, etc., and we found that it was not so unfair to use it like that. So that's the only place we could fit it anyway. So that's where we are. And the other big thing was more a terminology thing. Samita already did a big edit at some point, removing text about the backbone router, which really was not needed for this particular spec, was better fit in the backbone router text. Charlie came in with his review, and he still thought we didn't go far enough on that. And as it goes, in the meantime, 2 new pieces of work came up. One of them is role. Now we can use this document in a 6LoWPAN node to register to a 6LR, which is a REPL device. And thanks to this draft, the REPL device, the REPL router, can inject the registration into REPL. So it's kind of redistributing 6LoWPAN ND into REPL. So now the device, by just doing the 6LoWPAN ND registration, can get routing back from a REPL network. So that's different from a 6BBR, which is a proxy. So it's a second type of thing of reverse routability you can get from the registration. There is a third one. The other draft, which is actually a working group document as a Rift, also references this work as the way to register to Rift and say there is a sequence number. If you have a mobile device and it moves from a port to another port, or it's wireless or whatever, it's quite important for the routing protocol to know what is the latest location of your device. And that's one of those things that 6LoWPAN ND does. When you register to something, you increment sequence number, which is injected in REPL naturally, but it's also injected in Rift now. So that's how a Rift fabric knows the latest location of a VM or something like that. So because it was no more just the registration to a backbone router, we could not really keep mentioning backbone routers throughout the documents. And that was really one of the big thing that Charlie was pushing hard to do. So I talked to Suresh, actually. We had an exchange there because I was kind of reluctant to do a change like that in the document at that point of time. And, well, Charlie ended up convincing me, and it's mostly a change all. 6BBR goes away, And there is this new term, routing registrar. So you register to a router of some form or something which can do routing for you, and you get the packets back. The one thing which came at the same time is actually because of one of those two drafts I mentioned. Actually, it's useful for both, for Rift and for Ripple, is those protocols allow you to do multi-topology routing. So you can inject, there can be multiple logical topologies on your routing fabric, whether it's Ripple, it's called an instance, or if it's Rift. So if the node has a clue about which instance it would like to live in, then it should be able to indicate that in the registration. And we had this empty reserved byte here, so we decided to make it an opaque. And what it really is a way for the 6LoWPAN node to signal, for instance, Ripple, that it wants to live in this particular instance. And then there is the default, which is the default instance the router is using, probably 0. And the I field is just a way that we reserve to signal what the opaque is about, just in case. But right now we don't need anything. It's left to 0 because the opaque, if it's set, is just the instance. That's pretty much it. So summary is, for all I know, it's completely ready. I would like to Eric to confirm he's happy, and we need to sort out this reference thing with Suresh, and all set.
Carrie Lynn. So recently on the 6-man list, this recurring discussion about /64s has flared up again. And one of the dominant arguments for /127s is that routers are subject to resource exhaustion attacks from classical ND, and that using /127s is an attempt to sort of insulate backbone routers from this possibility. I'm just wondering whether you guys have discussed or thought about backporting any of these features to classic, ND.
That's a very, very, very good and interesting question. And the answer, yes, we've thought about it.
Yeah.
And I really hope it happens one day.
Well, specifically the registration. I mean,
Yeah, I spent about a year or two on that, and then gave up. I mean, it is unfortunate, but it's sort of this notion that there are different communities, different sub-communities of people that only care about phones, Wi-Fi, and Ethernet, and like, oh, this 6LO, that's a different universe. Why should we even worry about that stuff? Go away, right? So, and I think that's suboptimal, but that's the state of things. So, I mean, there have been drafts, I forget what they were called, but the various drafts that I've co-authored in the space to move it along. There might still be opportunity to go do stuff. One of the things that people have pointed out, and it keeps on showing up, is that duplicate address detection is expensive because it takes a second if you follow the spec, right? So this showed up in some discussions in IP Wave as well, saying, okay, if you follow the spec, we wait for a second to tell the car that we should want to talk to it and start a security exchange to tell us that we're hitting the brakes, right? I know that doesn't work, right?
It works, but
so there might be opportunities to go do something about that particular DAD thing. But the other one, the /127, /120, there are RFCs that say this is reasonable operational practices under these constraints, right? And yes, 6-man keeps on spending time on this stuff, but actually deployed networks router to router links, they, as far as I know, in many cases they use longer than /64. So.
But I must also say that since this discussion, actually we got Lorenzo in this room who asked us to do some changes, which we made. And I hope that makes the spec more acceptable now than it was at the time. So we'll see, I mean, but let's conclude it here and then see what we can do at 6-man with it. The other angle is that there is this IEEE IETF coordination thing, which has been discussing V6 over Wi-Fi and broadcast and all those things for like 4 years. And Dorothy at some point pointed out, .11 share, pointed out that Wi-Fi specs mandate the use of proxy neighbor discovery, but there is no spec for it. And so, on the other hand, now if you take this registration mechanism plus the backbone router, all of a sudden, yes, we have a spec that is mandatory to implement in Wi-Fi. So putting things together at some point should make sense. So I mean, sometimes it takes 10 years, right? I mean, we're not there yet for the registration. We're there for the fragmentation, and you see now it's coming. So we'll see. Lorenzo is coming as well.
Lorenzo Colletti, I think for 802.11 proxy ND, there is a spec. It's in the 802.11 spec. It says what it's supposed to do. So I think it's written down at 802.11 what the AP, how the AP is supposed to proxy these messages.
I've looked at that and I've not found a detailed operation for a neighbor discovery proxy. How do you associate to it at layer 3? How do you maintain this association? What do you do on every NT exchange? I don't think it's there. Now, if you show me the pointer, I'm interested.
I mean,
it's all layer 3 specifications. I'm not doing that.
Your assertion is that they say you must do this without telling you how. I don't think they published that. We can look. But
that's what I understood from Dorothy.
My recollection is perhaps that it's not as well specified as you'd like. And it's certainly not an IETF standard, right?
Right.
But I think it is specified in some way. I think I read it. We could go find it.
Yes, that's interesting. Anyway, one of the goals for backbone router is to do that, at least in the case of an IoT. It really describes how you associate. This is really a layer 3 association process. And then the backbone router is what you do in this proxy operation that is under-specified.
Okay,
Quick.
So for this particular request, we have heard this question at least few times in different contexts. And I think in conclusion, I think it would be good to discuss it again with our ADs and the 6-man chairs to see if there is any, if we can revive any work from the past that was kind of now put in the back burner.
Yeah.
I would only recommend doing that after this is out.
Yes, exactly.
Yeah,
I'm completely on that side. We are done with this. Let's publish it.
Yeah.
And if it needs to be amended to work on various other environments, let's create this other amendment RFC where it belongs, even if it's very thin.
Yeah, that's a good point.
So APND, we had interesting talks with Eric. Mohit is in the room, I think. But so please correct me if I'm wrong. But what I got is, I understand that Eric is happy with the fact that we can carry rover of 128 or 256, and he understands and he agrees that we can protect what we want to protect with that. It was a lot more discussion if we wanted to protect it with 64 bits. And well, we don't enter that because I mean, whoever wants to use a key of 64 bits, it's his prime, but we really enabled, and that cost us a lot of effort, rovers of larger size to provide the real protection. So that's done, that's in the spec. There was a left to right, right to left issue which we solved actually. Eric found out that usually when you truncate a token, you truncate left to right, but in 6775 we truncated right to left or something. So and in APND we did the other way around, so it was kind of bizarre. So we align the two specs and we do the normal left to right operation. So for instance, if you have this case where your 6LBR is not upgraded to the update, so it only allows 64 bits, EOI 64, you have to truncate the rover. And that still allows you to check that it looks like the same rover, at least for those 64 bits. But if you want to validate it as a key, you need, on the 6LR, you still need the real thing. But just to post it on the 6LBR and maintain the classical operation of the 6LBR, you have to truncate. And so we fixed it, so the truncation is the same as usual. And that was done before last time. We actually aligned our options to sound. We had different options, and that was consuming more option space. So we said, hey, why don't we overload the send options and use the same numbering space, just extend the name. For instance, one CGA option, one of the send options was called RSA, right? We are doing only elliptic curves, so we could not have an option called RSA. But I mean, just change the name, use the same code, just say it's overloaded, and that's what we did. So if there's a problem with that, just let us know. But the alternate is to consume more space in there, and that looks silly. Yeah, so all this is done in extended D. Yes, there's still this discussion about how we encode the key. And there was a question by Eric in this discussion. He said, hey, if you're using EC keys, you don't even need to use any of those complex DARE or GWK encodings. And, well, that's beyond me, right? So I hope that René helps us when he joins or something, or maybe Moit sorts it out. But the encoding of the key is way beyond me. I understand that DARE is complex. I've looked at it and say, oh, I hope we don't need to do that. But I mean, I don't understand why we don't just throw the key in there, like the bits. So that's beyond me. And it seems that Eric is saying the same thing. So that's it. And then you will find the flows there. Should I talk about bundle water?
Yeah.
Well,
there's a question on the JavaScript from Abdul Salam Barian. Is this update implemented?
the RFC 67.7 update or the APND? The APND, I don't know. The rest, yes.
Okay.
So Pascal, what's the status of 6LO APND? Is it now ready to move forward?
Not just now, but we are meeting with René, who was kind enough to come here. So right after this meeting, we spend an hour with René.
Yeah, I think, Mohit, I think we need one iteration more before, so not yet.
Right now, we should focus on backbone router. It's a big thing, and I know Charlie at least has some work he wants to do on there, and I hope other people as well. And so let's do backbone router, and give us time for the security aspect of APND. We're close. I mean, we have the right options now, which was not the case earlier. We have a good feeling of what it does, but edition-wise, it's not fully ready. And we want René as a co-author, and we discussed that last time. René did not spend time with us since last IETF, so it's going to be now. And that's it. Yes. So there was this R bit that we added in 6LO-ND, right? Our 6775 update to indicate I want routing. Well, we had to echo that in the backbone router to say, oh, now I'm doing routing if there was the R bit signaling me that I want to do it. So that's pretty much the only change. Then we get some clarification text. And I expect that if Charlie starts spending the same kind of time he spent on the other draft, then there will be a big addition on just making it clearer and conciser and whatever, Englisher. So there will be a pass like that, but it won't change the content. It's the function, function-wise, it's complete. So I think we can call for workgroup last call and integrate Charlie commands as part of the workgroup last call.
Sure.
It was implemented, by the way, as well.
Okay. Shall we ask how many people have read the draft at this point? How many people in the room have read the draft on the backbone router? Okay. Okay, 4 or 5 hands. We would like to have at least 1 or 2 reviews. Maybe we will, actually we request a volunteer for a review. Okay, Charlie. Okay, all right. So I'll also do some reviews, so maybe that way it's better. Okay, so next is BLE mesh, Carlos.
Okay, hello everyone. My name is Carlos Gomez, and I'm going to present the current status and the last update of the draft entitled IPv6 Mesh over Bluetooth Low Energy using IPSP.
Okay, we can do that.
Okay, so first of all, let's take a look at the status of the document. So the last update is -03, which was published a couple of weeks ago. So as you may have noticed, the document had not been updated for a while. That's because the previous version, 02, had been considered stable by the authors. Then we thought it would be a good idea to validate the draft by means of having some running code before actually requesting a working group last call. So since then, progress on this side, the implementation has been slow for several reasons, including what I'll present next. So our idea was to start from some running RFC 7668 scenario. That's IPv6 over star topology, Bluetooth Low Energy. So we started with the first approach by using Raspberry Pis, running BlueZ, which is the Linux BLE stack, as a basis. And while we were able to successfully run a simple scenario with one 6LBR and one 6LN, which correspond to Bluetooth Low Energy master and slave, respectively, it was not possible to have a more complex scenario running with one 6LBR and several 6LNs. And that appears to be because of some known issue of BlueZ, by which a BLE master doesn't really handle well several simultaneous Bluetooth Low Energy connections. And unfortunately, there's not a solution to that issue as of today. However, fortunately, we found another approach, which is using Bleach as the basis for our scenario. So Bleach is an RFC 7668 open source implementation for Contiki, and we have been able to locally reproduce at UPC one scenario comprising a 6LBR and several 6LNs communicating simultaneously. Next, please. So this is a picture of the devices we are using. This is CC2650 devices running Contiki OS. And from here, now we have actually already started to implement the draft. So this is now something which is in progress. Next, please. So now let's take a look at the updates in 03. So first of all, we have a new author, Michael Spork from the Graz University of Technology in Austria, who's also the main author of Bleach. And we also have a new contributor, who's Carlo Alberto Buano, also from the same university and also related with the bleach effort. So we have some technical update in 03, which arises from the fact that in the previous version, in 02, we assumed a network with already established BLE link layer connections. However, in 03, now we detail which is the relationship between 6LoWPAN roles and IPSP roles for connection establishment. By the way, recall that the IPSP is the Bluetooth profile that defines functionality for link layer connections and discovery of devices that support IPv6 over Bluetooth Low Energy. So as a result, we have added text in the section that deals with neighbor discovery, that's 332, and we have also added an appendix with an example. So more specifically, in the neighbor discovery section, we have added item 3B. That's because section 6.2 of RFC 6775 states that for dynamic configured scenarios, a 6LR comes up first as a non-router, then it waits until it receives an array to configure its own interface address, and then finally turns to a router. So in order to support the same operation, the idea is that in our draft, 6LR starts by using the IPSP node role only. Then this means that the device will advertise its presence by sending BLE advertisements. Then some previously existing IPSP router will be able to detect these advertisements and will initiate the establishment of a BLE connection, BLE link layer connection with the 6LR. Then at some moment, it will be possible for the router to send a router advertisement, which will be received by the 6LR, which will then configure its interface address, turn into a router, and then will start running also as an IPSP router. So for all of this to work, the idea is that the 6LBR needs to be running from the beginning as an IPSP router. So here we have some slides that illustrate, well, the example we have in an appendix, which try to illustrate an instance of this behavior. So initially, let's assume we have all these devices with these 6LoWPAN intended roles. And let's assume that at the beginning, they are not initialized, except for the 6LBR, which starts from the beginning, let's say, running as an IPSP router. Then, next please. At some moment, let's assume that a 6LR starts running initially in the IPSP node. It will start sending BLE advertisements that will be received at some moment by the 6LBR, which will initiate connection establishment. Next, please. So over the created Bluetooth low energy connections, it will be possible now to transmit IPv6 packets. And at some moment, the 6LBR will send a router advertisement. And then it means the 6LR will be able to configure its own interface address and will be able to turn into a router. So at that moment, the 6LR can start running as an IPSP router. And on the other hand, whether it continues or not running as an IPSP node in parallel is an implementation choice. Okay, so this is allowed by the IPSP specification, and at our 6LO level, this would be something to choose from. So at that moment, let's assume the rest of the devices, the 6LNs, at some moment will start also running, in this case, only as IPSP nodes. And now it means that the 6LR at some moment will detect the presence of the 6LNs and will be able to initiate the establishment of link layer connections similarly to the process we have seen before for the 6LBRs and the 6LR. So, after all, this is the result of this whole process by which at the end we have links with link layer connections established between neighboring devices, and it will be possible to transmit IPv6 packets over these established link layer connections. Well, finally, one last slide about some related work. Basically, question.
Hello, Carles. You left me a little bit confused on, is it a layer 2 mesh or a layer 3 mesh that you're building? Because you're not showing how the routing occurs.
Yeah, the idea would be to have routing at layer 3, IP routing.
Okay, so what would be the routing protocol? Are you using report?
It's not specified,
Okay.
so we leave this open in the draft. Okay, so one slide about related work, basically because there have been some questions on this in previous meetings about which is the relationship between this work we are doing here and also the Bluetooth Low Energy Mesh work happening at the Bluetooth SIG. So last year there was a set of specifications, the main one being called Bluetooth Mesh, published, which enable BLE mesh networking, which allow, well, this is actually a complete protocol stack which uses control flooding over advertising channels as the technique to enable end-to-end communication in a multi-hop scenario. One related note here is that RFC 7668, which is also the basis for our draft, assumes link layer connections over data channels for IPv6 over BLE. So it means, well, data channels are a different story with different formats, and currently at the IETF we don't have a way to carry IPv6 packets over advertising channels. So anyway, it appears that the current scenario is that we have at least two options to create Bluetooth Low Energy Mesh networks, the one defined by the Bluetooth SIG and the one we are enabling here. So that's all from my side. I don't know if there may be other questions, comments.
Any questions from the group? So this is a working group document at this point. So we are going to move forward with that. Do you think that we would need to revise it more at this point? Maybe one more. Maybe we will find some reviewers from the Bluetooth, some knowledge in the Bluetooth area and IPv6 area. Right?
Yeah, so getting more feedback would be great. And also in parallel, let's see if we can also progress from the implementation side to also have some additional feedback from there.
No, that sounds good. I think you're starting to get some experience from implementation. It sounds like you might need a little bit more, but it may not be too early to start seeking feedback from other folks. So we can do that.
Yeah. Thank you.
Thank you. Maybe you can start while it's coming out.
Okay, thank you. Thank you. My name is Yonggun Hong. I'm working for ETLI. So this is the 6LO calculability and use cases. This is the history and status. Could you explore up? Yeah. So 2 years ago, this document was adopted as a working group document. So this is the 5th revision. So I would like to emphasize the goal of this document. This document is not the technical document. It is information document. So the purpose of this document is to help other person to understand the 6LO technologies and how to deploy this technology into the real world. So it's the reason. So to do this, the many persons are attending to developing this draft. The main author of the 6LO overview document and other person from, for example, Drew Python Mesh and Yson and G3 PLC and Netricity experts help to develop this document. So this is the update part after last meeting. So there is nothing to add newly. We only delete two parts. One part is the LT-MTC. So in the beginning time, the LT-MTC was included in our draft, but in South Korea, especially the SK Telecom, we deploy LT-MTC in Korea, and we found that 6LO technology is not needed to deploy LT-MTC because LT-MTC itself supports IPv6 transmission. So LT-MTC is not related to 6LO technology. That's the reason we delete the LT-MTC part and the references. We found that NB-IoT case, it is needed some kind of the 6LO technology, but NB-IoT is held in the LPWAN working group. So I do not handle the NB-IoT in this document. And we also delete 6LO PLC references. The reason is it was expired. So I hope the new, I found that the new 6LO PLC document was raised, and I know that the Bing Liu will present. So I hope this 6LO PLC document was adopted as a working group document because in the real world, for example, G3 PLC and Netricity are based on the PLC technology. So I hope the PLC document was adopted as a working document. So in my side, the remaining work is two parts. One is the update Netricity. The currently Netricity is the home plug power alliance, but internally it is transporting to Yson alliance, but there is no official announcement. So that's the reason I keep the Netricity is the home plug power line alliance. So after official announcement, we will update. Then, so in our side, we believe that there is nothing to add newly. So I would like to ask the working group last call, the other person. Next please. Yes, that's all. Thank you.
Okay. No, if no other comments, thank you very much. And let's see.
My name is Youngwan Choi from H3. This is the IPv6 over NFC, actually the draft version number 10. This is the first slide, is quick introduction of the NFC technology. Here, can you make it the center? Yes, thank you. This is the history and status, the working group adoption at March 2015. we have 5 times revision and 4 times revision for working of last call. And actually, at the moment, this document is in working of last call since the March 2018. And there's no more feedback from the NFT forum since the January 2017. And we have a new shepherd, Samita. And Samita gave me the review of this document, version number 9. And I just produced the number 10 will be published as possible because I just get the review after the draft submission is expired today. So first comment from the shepherd is about the MTU of the NFC. Actually, the last paragraph is not clear, she said. So I just put the red box with the figures. This is the example of the MTU extension of NFC. So I just got the okay from her. And regarding the MTU of NFC, there's 2 paragraphs, 2 sections, the link model and the FAR. The firstly, link model, actually just NFC MTU can be available, can be extended. So this MTU cover the whole IPv6 packet. So we can use the FAR or not, just if we use the extension of MTU, NFC MTU. So just she gives a comment about the second paragraph. So I just put her the comment that this document does not recommend using FAR over NFC link due to the simplicity of the protocol and implementation. And also the section 8 for the A, FAR, just the first 3 sentences are simplified, just the one sentence, like this. Like this, the first sentence is simplified from these 3 sentences. The IPv6 NFC fragmentation and the assembly for the payload is not recommended in this document. That's discussed in the section 3.4. Actually, the rest of the paragraph is the same. And the last one is she gives a comment about the secret consideration. Actually, just put the last two paragraphs. She gave the comment just this document should caution about the threat for the main in the middle attack. And when the NFC device is connecting over in the internet. So just put some text at the end of the section 7, and she gave me the revised text. I just put the text from her. That's all. Thank you.
So any comments? So Gabriel and I discussed about the changes in this document. So originally there were many shells in this document, all over the document. So I requested Young-Hoon to change them appropriately to should, must, recommended, not recommended. So he has made those changes. What we discussed, Gabriel and I, that it would be appropriate that it should go for 1 week short last call in the working group. So please, we will do that probably immediately today or tomorrow, and please provide us comments. Thank you.
Thank you.
is fragmentation, and next is PLC. Yes, please. Isn't it working? Okay, then
Well, no, previous one. Yeah, thank you. So currently we arrive at the fourth version of this draft. And in this version, we have formally included the IEEE 1901.1 into the scope, which is a recently published IEEE PLC standards. I will give more details about this PLC. And the address auto configuration and the mapping mechanisms have been included in this draft. And the related features in the RFC 6775 update has been introduced to this draft for the neighbor discovery of PLC devices. And Charlie Perkins and I have become the co-authors of this draft. Next page, please. And for the IEEE 1901.1, it is a newly published IEEE PLC standard by the Smart Grids Power and Communication Working Group. And it works in the medium frequency. It has the following characteristics. It supports both TDMA and CSMA in the frame. And it utilizes the OFDM modulation to deal with the interference on the power lines. And it also supports the fragmentation and the reassembly, data retransmission, and multiple ways of data encryption, and 4 levels of priority of different queues. And the data rate of IEEE 1901.1 can be up to 2 megabits per second. Next page, please. And for the stateless address auto configuration, the interface ID can be derived from the long address, which can be the EUI 64 ID or the 48-bit MAC address, and which can be extended to 64-bit by inserting the FFFE in the middle. And the UNL bit should be set to 1 to indicate that it is a global unique address. And the GI bit should be set to 0. And another option for stateless address auto configuration is to derive the interface ID from the short addresses. Questions?
Yes, Carrie Lynn. I just want to give you a heads up. Is this only used for link local traffic, or is it also used for routable traffic?
If it is derived for, it can be used for multiple link traffic.
So so one thing you might run into as this gets further down the pike is pushback from IESG on the privacy aspects of this. So one thing you could look at is the way that I finessed this in 6LO back. This is fine, I think, for link local traffic.
Yeah.
But if you start, I think you're going to get resistance for using this scheme for routable traffic, because there's, just a lot of concern about exposing hardware addresses in IPv6.
Okay, thank you. And another option is to derive the interface ID from short addresses. And here are the formulas that we defined in this draft. The difference between the difference comes from the a different combination of short addresses for different PLC standards. And the U and L bit and the GL bit should be set to 0. And it should be clarified that the U and L and the GL bit must not be used to generate the NID or the PID to avoid any ambiguity. Next page, please. And for unicast mapping, link layer address option are defined, which can be used for the neighbor discovery to resolve the link layer address and to surprise the broadcast in neighbor discovery messages. Next page, please. And we have also included the RFC 6775, the new features to these PLC devices. And the updated PLC devices should include the EARO in the neighbor solicitation. So here I mean neighbor solicitation instead of router solicitation. And the R bit should be set to 1 if the PLC device can be it is not, if the device is not, it is not a router. And the R bit should be set to 1 if the device is in charge of, should be set 0 if the device is in charge of its own reachability. And the updated PLC device should use the EARO to extract the status registration from the neighbor advertisement message. And the DD can be proxied to a routing register, which may operate in optimistic DD. And for the to achieve the backward compatibility to RFC 6775 only PLC devices, the rule of 64 bits must be used. And next page, please. So next step, we think that this draft is ready, and we will call for working group adoption. And before this, your comments are more than welcome. Thank you.
Thank you. So how many people have read the this draft? Sorry. 2. I think we need more people 3, 4. We need more people to read the draft to ask for working group adoption.
Okay, thank you.
Yes, please read the draft and send comments to the mailing list. And after that, we'll request a working group adoption.
Thank you.
Anybody have the blue sheets? Anybody hasn't signed the blue sheets? Where are they?
Next is Thomas Watney. He is going to present remotely. We are going to have 2 presentations on fragmentation reassembly, basically handling the fragments. So we'll see. I see Thomas appearing. See him in a small picture. So Thomas, take it away. I am just going to change the size of the presentation to the presentation mode. Okay. Thomas, can you hear us? Thomas, are you in mute? We can't hear you. Is there any way to communicate with him? Do we have to do anything?
Supposedly, we don't need to do anything. Double check if we need to go with Thomas, and he's got it all set. Google says there's, oh no. This was tested already.
Juan Carlos Zúñiga, you may want to play with the little button, the blue button with the speaker on the button.
The button I pressed, his picture disappeared because of that.
We don't need to do it. Double check. See,
Gabriel, can you ask Thomas to request to be on the queue again?
Let's swap the presentations. So Pascal, could you go up? So Thomas is trying to rejoin. So he's asked for Pascal, if you could go first, that'd be great. In the meantime, we should get Thomas.
So once upon a time, there was a draft about fragment forwarding and recovery, which has been there for a long, long time. And then the bones finally made it to the surface, and the working group decided to work on fragments some time ago and formed the design team. So I'm doing the introduction on behalf of Thomas here. So this initial fragment forwarding draft really had two parts. How do you forward fragments and how do you recover fragments? For the first piece, you don't really need to change the formats from the legacy 6LO pad. For the recovery, you do. So part of what the design team decided to do was to split the work into two pieces, one which does forwarding of fragments and one which does recovery, the latter being this draft. Since we did that split, I removed from the original fragment forwarding draft everything about fragment forwarding, which caused me to change the name because it kind of made no sense anymore. So the good old, next slide, please. The good old fragment forwarding draft became the fragment recovery. Part of the fragment recovery is to expose a bitmap, which is pretty similar to what we do in LP1, of which fragments were received and which one were not. We also enable windowing systems so that you can limit the number of fragments which are in the air and avoid congestion in the network, and use an ECN bit to actually signal that. Next slide. We also signal the end of a flow so that you can clean up resources inside the network. So just published the 01 version, and the change from 00 has to do with the discussion we had at the last IETF, because Karsten insisted that with the forwarding technique, we could actually keep some bytes from the previous fragment and use them in the next fragments, etc., etc. On each fragment, you can actually, you don't have to have one fragment in, one fragment out. And the reason why it would happen that way is 6LO pan compression may not happen the same way when the packet comes in, and when the packet goes out. Reason is, for instance, that if you're one hop away from the source might use the MAC address at layer 2 to compress the IP address at layer 3. But once you forward the fragment, the compression doesn't work anymore. You have to put the full IP address as source. So you end up with a packet which is smaller on the first hop than later. If you fill up this packet without any slack in your room, then the next hop has to truncate the fragment, keep some of it for next time, and forward what it has with now the full IPv6 address uncompressed in 6LO pad. So that's a very sad thing, if you ask me. Anyway, the fragment recovery cannot work like that because you signal individual fragments that were not received. So you want the bit which means fragment 5 to mean the same thing at the source and at the destination. You can't redo where you fragment on the fly in the middle. So with this draft, compared to the generic virtual buffer that Karsten and Thomas are writing on.
Can you hear me?
Yes, Thomas, we can. I had to insist that if you have this kind of network where the 6LoWPAN compression is not the same all along, and you need to have slack, then you put the slack on the first fragment. So as you forward the first fragment, which was where the 6LoWPAN compression happens anyway, if the size of the 6LoWPAN compressing changes, you don't change the content, the data piece of the fragment. So all the next fragments are forwarded in their integrity. They are not, you don't resplit the fragments. So that's just a new text, that's the discussion. Now, my thinking is that this should be true regardless. I mean, having to change what the fragments are in flight and not send the exact same datagram in and out, that's additional complexity. I don't see the value. I think the slack should always be in the first fragment, but that's just me. If the group has any feedback on that, I'm interested.
Rahul Jadhav from Huawei Technologies. So we are implementing this in production code, actually, the fragment forwarding technique, and we are using the slack. We have to keep slack for the first, not only for the addresses, but for other fields as well. For example, TTL, which has to be changed on per op basis, so that also has to be changed again.
So you put the slack in the first fragment.
Yes,
yeah,
yes.
I mean, that makes so much sense. I think we should mandate it.
Mm-hmm. So I should be online now. I don't know if you still want to go there or if you want to move forward.
We're right for you.
All right, so apologies for the microphone thing. My flight got canceled, so I cannot be there. So I have two very quick parts of this presentation. One slide on the design team, three slides on the draft. The design team, next slide please, has been scoped with what Pascal just said. We have presented a problem statement and goal last IETF. We now have 3 drafts, and I think this will answer Carrie's comment. We have one in LWIG and 2 in 6LO. The one in LWIG discusses the implementation technique of fragment forwarding. The first one in 6LO, draft number 2 here, details the context and what fragment forwarding is, and what is currently defined and what needs to be defined, if anything. And then the third one does fragment recovery, which is what Pascal just presented. So last IETF, I think we said we wanted to close the design team as soon as those drafts were adopted. The LWIG document has been adopted. The 2 other ones have not been adopted. So I believe that the design team is still open, and the goal here is to ask the chairs whether they want to adopt these drafts and we close the design team, or whether we don't want to adopt these drafts and we still close the design team. So the next slide, this next part is on the minimal fragment forwarding, which is next please, which is giving some context about what is being defined now. I don't know, Samita, maybe you can move forward 2 slides. Yep, thank you. So we posted a new version, Karsten, Pascal, and myself, a couple of days ago, where we highlight the limits of per hop reassembly, fragmentation reassembly, and then we discuss the VRB implementation and its limits, and that VRB implementation is being discussed in the LWIG draft that Karsten has. Next slide, please. So here again, reiterating what the 3 pieces are. The LWIG draft details an implementation technique called VRB. This current draft here about 6LO provides some overview of what's happening and highlights the limits. And then Pascal's draft adds defines a new protocol to do end-to-end hacking and recover fragments. Next slide, please. And that's my last slide. So the authors as a 6LO chair is to call for work group adoption of this draft. That's it for me. I hope this answers your question, Carrie, and I'm happy to take questions.
So I think the chairs agree with that position. So anybody object to asking for adoption here? Seems like we're ready for that. Of course, we're going to do it on the mailing list, but I'd like to get some sense here. There's anybody who agrees to adopt these two drafts as working group drafts? Let's just raise hands, I think. You raise your hand if you support adopting these as working group drafts. Okay. You don't know, you don't care? Yeah. I saw about 15-ish, something like that, which is a good amount, a good percentage of the people who are.
Just for the record, there's one voice from the Java as well. One guy.
Okay. So yeah, I think we're gonna go ahead and of course, pose a question on the mailing list, but pretty sure that's what we're going to do. And once we formally adopt them, then we can declare the design team closed with our thanks for their good efforts.
Thank you. So we record that there is no objection in the room today. Okay, thank you.
Thank you.
Thank you, Thomas. Okay, so next is a new draft by Hudson and Phil on design consideration for low power internet devices.
Hi, everyone. My name is Hudson Ayers. I'm a PhD student at Stanford, and I'm going to be presenting some research I've been doing into design considerations for low-power internet protocols, and I've been doing this alongside a few other students at Stanford, as well as Amit Levy and Phil Levis. So some of the motivation for this research is, of course, grounded in the idea that interoperability is crucial for IoT devices and for low-power embedded protocols. And while working on a 6LoWPAN implementation for the TOC embedded operating system, we started looking into the 6LoWPAN implementations of several other open source operating systems, and we found a lot of variation. And ultimately, that inspired us to do a interoperability study into 5 open source implementations, specifically Kentucky, ARM Embed, Riot, TinyOS, and OpenThread. And one thing that we found was that for all of these pairings of implementations, none could completely interoperate for all of the cases that are defined in the 6LoWPAN RFCs for 4944, 6282, and 6775. I'm going to elaborate on this a little bit more later, but we think that one of the primary reasons for this is actually due to some of the constraints on code size and RAM as well. And so the internet draft that I presented that is associated with this talk talks about some principal designs and guidelines that can anticipate problems in this space. And we hope that this informational internet draft can sort of provide advice here and maybe prevent some of these problems for other protocols and sort of enlighten with some of the interoperability issues in 6LoWPAN. So this is an outline. I already sort of previewed everything here, but I'm going to elaborate some more on the motivation and the specific findings that we had. I'm going to go into my 4 design guidelines, and I'm going to illustrate them through example application to 6LoWPAN, and then conclude with some discussion, see what you guys think, and some of the takeaways that we had from our original results. So these are some of the results of the 6LoWPAN interoperability study that we did. In this column on the left, we have a list of sort of what we call the features of 6LoWPAN specified in 4944 and 6282 primarily. So these are a bunch of things that these different...
Just to confirm, is there a draft on uploaded for this on 6LoWPAN?
Yes, there is. And
There
it's-
is? Or- okay.
Yeah, if you go to the agenda, I believe it's linked.
Okay, thank you.
Yeah, of course. But yeah, so this is a list of the features that given implementation must support in order to be considered a full 6LoWPAN implementation. So stuff like stateless address compression and UDP port compression, and support for the mesh and broadcast headers, etc. And when we looked at all of these implementations, one thing that we found was that none of them actually seems to implement every single feature at least correctly as described in the specifications. And also that for these 5 stacks, the missing feature support was actually mismatched. So while some stacks would support one thing, others might not. And that sort of, to us, seemed to indicate somewhat of a problem. And so we investigated a little further. And we flashed some of these operating systems and some of their example 6LoWPAN applications onto different embedded boards and tried to send packets back and forth. And for many of the sort of common, more simple use cases, we found that it worked fine. But we would find that for certain packets that might be compressed in a certain way, we would suddenly have silent network layer drops. So for instance, from an embed OS device communicating with a Kentucky device, if given 6LoWPAN packet contained an IPv6 extension header, embed would compress the extension header according to the guidelines in RFC 6282, and Kentucky would not be able to parse that and would respond with link layer acknowledgements, but then would not respond because it would with any application data, because these packets would then be silently dropped at the network layer. And we found that we were able to actually produce sort of a lot of examples of this with the 5 stacks that we looked at and some of the different features described in that earlier 6LoWPAN table. And we thought there might be a few possible reasons why this is the case. Of course, these are open source stacks, and 6LoWPAN has changed a lot in the 10 years since 2008. So perhaps we thought maybe those could be the reasons. There's not necessarily an established reference implementation, like for instance, the Linux TCP stack that many people might look to when implementing their own TCP stack. But ultimately, we don't really think these are actually the primary reasons, even if they might have contributed. And instead, we think that a big part of it is due to concerns by the designers, or the implementers, excuse me, with regards to code size in particular. And to sort of elaborate on why we arrived at that conclusion, looking at the documentation and the comments and just the design of these stacks, it's pretty evident that the designers were, of course, concerned with code size. So if you look at some of the wikis for these various operating systems, you'll see guidelines on how to reduce the firmware of these applications and the kernel for certain cases. And we found that frequently the advice was to use these different methods to reduce the size of the IP stack, and often specifically the 6LoWPAN stack. So scattered throughout the source code of the networking stack in these kernels of these OSs, we would find ifdefs in a lot of places, such as this ifdef module GNRC 6LoWPAN IPHC. Or IPHC and HC. And so there'd be an option for whoever was flashing this operating system onto a given embedded device to disable, the NHC feature, the next header compression feature, or portions of the next header compression feature when flashing the device, in order to reduce the firmware size and just use this subset of 6LoWPAN functionality. If you could actually scroll down just a little bit. And for RAM as well, we found, for instance, in Kentucky, that it assumes that the maximum possible growth upon decompression in the first fragment is 38 bytes. And that was to conserve RAM and to avoid using more than 38 bytes of RAM for the first fragment buffer. And that 38 byte limit is one that can easily be exceeded when sending certain packets, given the amount that IP headers and UDP headers and extension headers can decompress. And so to elaborate some more on this problem and why it might happen in particular for these embedded operating systems, if you look at a number of the 6LoWPAN platforms with 15.4 radios that are supported by Kentucky OS and Riot OS, I just sort of grabbed a sampling of the boards. You have platforms that are small as the T-Mode Sky which, while it might be considered more of a legacy mode, is still used for research applications. Some small platforms like the Zalairtia Z1, both of these which have less than 100 kilobytes of code size available. And then you of course also have much larger these Cortex-M devices, and then even consumer devices like the Nest Protect, which are much more resourceful. And what we found is that these embedded operating systems, they really want to be able to broadly support large numbers of devices. And so they want to be able to have kernels that are very small and networking implementations that are very small, so that while they might work well on the larger devices, they also can be supported by the smaller devices. And it's rather rare for these embedded operating systems to have significantly different implementations based off of the size of the device that's being flashed. And we found also that for the IoT applications that many people use these embedded operating systems for, the limitations varied a lot. For some implementations, power might be the biggest concern, but for other implementations with relatively complex applications, sometimes it was the case that code size or memory availability was also very important and could influence decisions regarding which embedded operating system might be used. So to get some more concrete numbers for this, we tried to do a 6LoWPAN code size study for these 5 stacks. We did this using 2 methods. For Kentucky and Riot, we did our best to take advantage of the options to disable portions of the 6LoWPAN stack to isolate how much code size was attributable to those portions specifically. So for instance, in Kentucky, if you enable the options to remove IPHC compression, that would reduce the code size by about 6 kilobytes. In Riot, relatively similar numbers. And then for OpenThread, ARM Embed, and TinyOS, we looked at the binary ELF files and figured out how much code size was attributable to each of the functions that are associated with 6LoWPAN and with the full IP stack. And obviously, these numbers for the IP stack and for 6LoWPAN are not necessarily huge relative to the amount of program memory available on a lot of these devices, but I think it would be foolish to consider that they're not significant, especially for some of the smaller devices, and especially for cases where applications might have a significant amount of code. And that sort of leads us to a discussion, maybe an aside, of the interaction between code size and compression. There's a lot of things that you can do to reduce the amount of radio energy used by a given embedded device. Beyond just compression, there's also advanced MAC and physical layers, which can reduce the amount of radio energy expended by a given device. But the trade-off is that these often, A, require more compute power, and B, they're often relatively complex and can require additional code space or RAM. And for cases where you have an application which might already be pushing up against the boundary of what's capable on a given device, it can force a requirement for more expensive or more power-hungry microcontrollers. I'm actually going to... there's some other considerations as well. Just in general, increased complexity can be harmful to expectations of interoperability. And it's difficult, for instance, to apply something like Postel's law to this low resource environment. And that sort of brings me to my 4 design guidelines. And in the slides that follow, I'm going to present each guideline, and then I'm going to follow it up with an example application to 6LoWPAN. And while I'm committed to the guidelines, and I will defend the guidelines themselves, I'm not super committed to the specific examples, and I'd like to avoid any discussion that follows getting too tangled in necessarily the specific details of the example apps, because I believe that while those example apps themselves may not be perfect, they're useful for illustrating what the design guidelines mean and still worth discussing. So for guideline 1, this is actually slightly different than the order that I present the guidelines in the internet draft for anyone who's read it, but I think that's sort of logical here. I think it's important that these devices have the ability to advertise their capability so that these silent network layer drops, which cannot be interpreted as anything in particular by a given sender, cannot occur. Right now, it seems sort of unconscionable that for 6LoWPAN, it's relatively easy for these 5 different stacks, to send packets which will be silently dropped with no information back to the receiver. And so long as there's an explicit mechanism defined in the protocol by which this can be avoided, I think that that's important and useful. For 6LoWPAN, I propose 2 potential mechanisms for this, which could either one could be used on its own or could be used in tandem. I think one of the more important ones would be just including an ICMPv6 message type to indicate if a given device receives receives a message which it cannot parse at the network layer, and so it can respond to the sender and indicate that perhaps its capability was not sufficiently high to parse that message. And then the second option would be an additional 6LoWPAN neighbor discovery option, which would allow for a device to communicate some amount of its capability during the time when devices are learning about each other in the network. And this option minimizes this additional energy cost of responding with failures as would be required for IC and PV6. And of course, given that these devices need to be able to advertise their capabilities, the next logical question would be, what exact information should they be advertising during this process? And so what we propose is that in general, these protocols should define a capability spectrum. Given that there are often a relatively broad range of capability devices that might want to use a protocol, and that some of these devices may be very concerned with saving power, and others might be more concerned with code size or RAM use. It's important that there be a capability for a given protocol that defines how the features of this protocol can be removed as code size needs to be conserved. This is actually somewhat similar to an idea presented in Jonathan Wee's 6LoWPAN interop draft in 2008 that discussed testing interoperability of independent implementations. And so for 6LoWPAN, here, this actually includes all of the features from that slide that I showed earlier, and how they could be split up into, for instance, 6 classes. So for instance, a class 0 device in this scheme would only support sending and receiving uncompressed IPv6, which can be fragmented according to RFC 4944. And then a class 5 device would support the entire specification, so everything defined in 4944, 6282, 6775. And then something like a class 2 device would support sending and receiving stateless IPv6 address compression messages, but wouldn't, for instance, support fields that were sent with IPv6 option compression. And so, the reason that we chose these specific classes is the idea that as you move up from class 0 to class 5, class 1 and class 2 are the classes where you get the most energy savings for the least added code size. And then for the higher classes, you have smaller increments of energy savings for relatively more complex additions to code. Then for guideline 3, just the idea that these protocols should provide reasonable bounds. This is based largely in our observations for 6LoWPAN that many of the stacks were taking certain shortcuts or defining certain constants that were not defined in any of the RFCs to serve RAM in certain places. So for 6LoWPAN, we, for instance, suggest that perhaps header decompression should be limited to 50 bytes so that for instances where more than 50 bytes of decompression would occur, those messages should actually not be decompressed or should not be compressed that much before sending. And that allows for implementations to bound the amount of extra RAM needed for initial fragment buffers. Which is something, for instance, that Kentucky already does, but Kentucky arbitrarily chose 38 bytes as the amount that they limited to. Additionally, we suggest that there should be either a bound on the amount of compression of interior headers for tunneled IPv6, or that that feature should be removed entirely, because from observing these 5 different stacks, it looked like there was a decent amount of complexity in terms of how these different stacks handled this possibility of unbounded recursion. And we also found that that seemed to be a place where the stacks varied a lot. And so that's why that second requirement is there. And then finally, guideline 4 is just this importance of not specifically breaking layering within a protocol. We realize that it can be very appealing to do cross-layer optimization in embedded systems, especially given how little energy is often available. However, it's very difficult to design robust systems that will interoperate well when you're doing this cross-layer optimization. The ability to use libraries, et cetera, can be very important, especially for these embedded operating systems where different network transport layers, et cetera, might be used. And for 6LoWPAN, the one primary application that we suggest there is that UDP checksum elision shouldn't be an option. We did notice that for the 5 operating systems that we analyzed, TinyOS was actually the only one that implemented UDP checksum elision. And we believe that the downsides of including it in terms of how it breaks the end-to-end argument, breaks layering, can be complex to implement because it requires these application and link layer checks for message integrity codes and permission from the application layer, that it's simply not worth the small energy savings that it can provide. So that's my 4 guidelines. I'd really like to know what you guys think about the different suggestions I had for 6LoWPAN, about the guidelines themselves, especially about the idea of adding this ICMP option when a given embedded implementation cannot respond to a certain 6LoWPAN message because it is elided portions of the specification. Please.
Pascal Hubert, so thank you so much for this work. You asked many questions. I just give you a few hints here. First, for your spectrum and bits, there is actually an RFC which would allow you to do that. It's Carsten's RFC. We are using it in 6LoWPAN update to signal like support for if you're a 6LR, 6LBR, etc. We use bits in there, so there's a good number of bits. So if really we want to do a piece of that, you could actually signal that and experiment with it. Now, it's not just signaling, it's having extra code to manage, oh, if he does that, I do this, if he does that, I do this. So what you're saving on one hand is a cost on the other one, right? So you're adding code to save code, so there's a limit to this game. To be discussed, I realized that you make big enough classes, because if you were doing 2 fine-grained classes, you would spend all memory doing all the possible cases and testing them, etc. So the real world is not exactly like that. The real world is, you mentioned thread, right? The real world has bodies which define interrupt tests. It's not 6LoWPAN. 6LoWPAN is more like there is a whole set of things you could be doing, right? And then there will be a Zigbee IP, there will be a YSUN, there will be a thread, there will be any of those guys, which was ISA100.11a, I'll come back to this one, which say, okay, out of all those things that 6LoWPAN enables me to do, here is exactly what I ask any implementation to do. And there will be interrupt test, and there will be conformance test. And even if your stack supports more, here's the bare minimum, because I know all the messages which will go through my standard, which is building on 6LoWPAN, but it's not 6LoWPAN, building on many things, REPL or not REPL or all those things. Here are all the flows that I'm going to support. I want your implementation to support all these flows regardless of what else it supports. And all will be tested and validated. And that's how actually, because you have this logo, I'm the ISA100, I'm Zigbee IP, I'm thread, I'm whatever, you know you won't get this problem you're talking about, not within one of those silos, right? So there is no real aim at 6LoWPAN support everything. To say, oh, you have to support everything, but each of those bodies will actually say what they really want. And an example of that, I said I would come back to it, is ISA100.11a. Those guys are doing an industrial standard for reliable wireless communication for process control. And they use 6LoWPAN. But actually, if you look at what they use from 6LoWPAN, it's a very teeny tiny piece. They have link local address, they have global addresses, but if you look at the frames they really send, they specify where I will be sending this. It's a very tiny subset of what you can do with 6LoWPAN, but it's enough to get their standards to work. And everybody who implements all those things. One of the things they mandated was to elide the checksum. And they came to us and they said, okay, if you want us to do IPv6 at all, then you need to provide a way for us to elide the checksum because we have a MIC at the end of the packet, which is 4 bytes. There's no reason for us, no way for us to transport those 2 extra bytes. You don't do it, we don't do IPv6. So we did it. So you see, sometimes it has to do with politics. You talked about upper layers and not no layer. Well, it goes all the way to 8.
Yeah, thank you. Just in reference to what you said at the beginning of when you were speaking regarding how there can be extra code to handle the different cases for a given capability spectrum. I think the bright side of the design of this capability spectrum is that the code for like deciding, oh, will I send at this level? Will I send at this level, et cetera, is at least offloaded onto the more capable devices. So for instance, a class 0 device always sends class 0, and a class 1 device simply has to decide between class 1 and class 0, relatively easy. And so it's actually the more resourceful devices that take on most of the additional code size. So there's sort of a fairness aspect there.
Thank you for this presentation. I think it's really interesting. The survey part, I think we should digest, and maybe there's some stuff we can do based on that. The overarching design considerations, I'm having some trouble, and I came here to basically say what Pascal is saying, that we in the IETF, we publish RFCs and we're happy, and that's fine, and they look pretty, but when it comes to the real world, they couldn't care less. They may take some hints from some RFCs, they won't take them all completely. I know for a fact. So I've looked at the specs for some of these organizations. They call themselves 6LoWPAN. There's no way a 6LoWPAN completely compliant per our definition implementation will ever interoperate with those that are called 6LoWPAN. So even if we here go through the enormous amount of work that it would be to basically restructure all our documents in the class 01, blah, 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 nothing guarantees they will even look at it or care about it, because they go about looking at what do we have to deliver by yesterday. They don't have the luxury of looking at the stuff. I understand where they come from. It's not like I'm blaming them. I mean, if I were there, I'd do the same thing. You have to ship yesterday. Okay, here's the shortcut we take. Here's another shortcut. Here's maybe something we think is honestly better. Maybe they have a better protocol. Instead of 6775, they might use some other. I've seen that happen. Fine. So they mix and match. They call this 6LoWPAN, but not really. So even if we do all this work here, there's no guarantee.
Yeah,
but
sure.
But still, I still want to thank you for this work. This is great stuff, and I'm sure there's got to be some lessons here. We have to take it back and digest. I'm just not sure the overarching thing might be one of those, but there's got to be something here. I'm sure we can learn from this. Yeah. Thank you.
I mean, I agree that going back and, adding in all of these capability classes, et cetera, there'd be no guarantee that everybody would do it. I still think this idea that we sort of acknowledge that we don't expect that all implementations will implement, every aspect of an RFC is particularly a convincing argument that, perhaps there should at least be an ICMP error code that can, convey when a given packet is dropped, because of that. So yeah, thank you.
Hey, fellows. So I just actually wanted to respond to that comment and Pascal's comment. I think that's totally right. I mean, there are these vertical silos. People, you have a standards body that's using 6LoWPAN as a basis for its underlying protocols, but there might be parts of the specification they don't want to use. And I think you're right. That's fine. That's the way the world works. But the question is that all we want 6LoWPAN to be? I mean, the internet is about connectivity. And if we want to relegate 6LoWPAN to only being suitable for vertical silos, I think that's one decision. But another decision is, can the specifications themselves instead enable interoperability where it's not vertically siloed? That's, we used open source operating systems. These are people who would like to be able to stick different devices together and get them to work, and they can't because there aren't these sorts of guidelines or capability spectrum to think about. And so I think those are two paths. I personally would like to see 6LoWPAN saying, look, of course, open thread, you're going to do what you need to do and all of that, or gosh, if you're going to do this UDP checksum compression, that's fine. You're doing it in your vertical silo. But then for that to sort of propagate out and make it very difficult for open devices to interoperate, that was kind of the whole motivation. That was what gave me pause and made me think it would be useful to have this discussion.
Samita Chakrabarti without the chair hat. Thank you very much, Hudson and the team, to do this work and doing the great analysis for different devices and coming up with a possible solution. I think partly I agree with the previous argument that, okay, we have interoperability test, we have different other considerations for implementations and their interoperabilities, but I kind of like the idea of the capability, but I have a couple of questions, like maybe you need to think about at what point you want to do this capability exchange? Is it like startup time or application running time? Maybe I think maybe we could ask the bigger group for if there are comments. But personally, I think this is a concept that maybe you are directing towards the capability of the memory and device capability. Maybe it could be used for some applications or some other way as well. So overall, I think the idea of having capability exchange is great. And whether we can use exactly the same way you proposed or not, that may be subject to discussion. But thank you again.
Yeah, of course, thanks. And I totally agree that the given capability split up that I put here is not necessarily ideal, and definitely could be open to suggestions or interpretation.
Two things. First, react to what Samita said. Well, if 6LoWPAN had that dichotomy and that ended up in the open source implementation, yes, surely that would have made the life easier for someone who wants to take a given open source implementation and use it in his standard or for whatever he wants to do with it, because we just have to cross a few checks, as opposed to look at the code and say, oh, does it do what I want? So it would make the code, the open source code, much easier to reuse in various cases. So, which is a bit of what Phil said, but it's another angle to say the same value. Now I'm reacting to Phil. When you talk about a silo, it's a lot more than 6LoWPAN. It goes from which file you select, how you do your security, which crypto utilities you pick, which option you put in your beacons. I mean, it's a damn big list of things, of choices that you make, so that at the end of the day, there can be an IPv6 packet through. It's awfully complex. So I don't really believe in a node talking to another node just like this. But the good news is that the silo is just a few hops. And IPv6 is really where Phil has it right. Yes, at some point, very rapidly, you expand this packet, you go out of this particular radio network. And now you have an IPv6 packet that you can fly through your network. So yes, I guess ultimately IPv6 achieves what we want to do, but it's way beyond 6LoWPAN prime, because what happens in this subnet is a lot more than 6LoWPAN compression. Sadly.
Yeah, sure. It still seems to be the case that while it's true that once you get to the IPv6 layer, going through a border router, everything can communicate with each other. But I think sort of like in terms of like the longstanding vision for Internet of Things devices, the vision isn't, for somebody who's using IoT for, home automation and stuff like that, is not to have, a border router for every single device they buy from every different vendor. It's, buy, a single router and, all of your devices communicate with a single thing. So it still seems like just totally accepting the silos. But yeah, thanks.
Yeah, I do agree, and basically what I said was I think there's something to rescue here. I'm trying to wrap my head around what could be rescued, and maybe there's something I've heard that I liked is like the ICMP message, for example. So maybe the way to think about it would be if we set out to guarantee interoperability. I think that's a very, very, very tall order. We might fail because there's so many things outside of 6LoWPAN that would affect ultimately that. But maybe the bar, at least to start with, could be a little bit lower, more practical, saying, okay, is there anything we can add to help the people who presumably know what they're doing to interoperate, just to do better troubleshooting? So it's not that they don't have all the set of information. In principle, they do, but still you make so many mistakes. There's so many variables, so many things that you need some help. Right? This is supposed to work. I'm within a silo or whatever. I'm not in a silo, but I'm in open source looking at the whatever. It's supposed to work because I have an agreement, but still I have no visibility. So if maybe that's a practical bar to start with, and that would be useful. And that would really help interoperability maybe in a more practical way than trying to boil the ocean.
Sure, I agree. I think that the ICMP recommendation is like the most imminently implementable and probably more useful than everything else.
Thanks.
And
Go to Thomas.
Thomas.
Yes. So I don't have particularly anything different to say, but I want to stress, the points that Pascal was making, and I agree with this. I mean, it's much more than 6LoWPAN, and it's so complicated. And trying to have yet another protocol that kind of announces the capabilities, it's just not going to work. And I think it takes a group of industrial people to come together and agree on, interop test specifications. I'm not talking about silos. I'm talking about, like-minded people, same kind of business case, and then they take a subset. I think this relates very much to the LWIC thing, and I'm not at all talking about your draft here, but I'm, one thing that I find challenging in what we do at the IETF is that if you take all the musts from all the drafts that are within our kind of IoT stack, it doesn't fit in the Pentium computer. So I think we need to be. It's very good that your draft highlights kind of some of these parts, but I think we need to be aware of the fact that the specs that we define, if we were to implement every must in every of these specs, it just wouldn't fit anywhere. And so making informed decisions about taking bits and pieces is impossible to avoid. Thank you.
Great. Thanks.
Terry Manderson, Interior Director. So thank you for doing this work. Really is appreciated, and it's a credit to your program. Good work. There's some aspects here that I really do like. I mean, the IETF has spent a lot of time doing capability negotiation, whether it's in BGP, whether it's in SIP, SDP, etc. The list goes on and on and on. So there might be some things to learn from that as to why it's not directly applicable in this very constrained environment. That said, I really do like the idea of the ICMP message. Getting that across the line, interesting discussion. At the end of the day, one of the things that did come out of what I heard on the line is that when you're talking about different very small form factor devices, it's not so much what they can communicate, but what you can stamp on them on the box to say, this might be a class 0 device, this might be a class 5 device, and that might be enough to get some understanding and to get interoperability to a point where it's accessible. I don't know, but it's just highlighting that. At the end of the day, however, that's a discussion for the entire work group. So great work, maybe come back a more solid document and perhaps running code and see how that goes. Thank you.
Sounds great, thanks.
Thank you, Terry. And also to respond to Pascal, that the charter of this group is not only the header compression stuff, but we can take any improvement or enhancement to 6LoWPAN stack. And I would say if we do correctly the capability with the ICMP messaging, if we find right application, I think it'd be a good addition.
Phil, very quickly. I think we're out of time, but please.
Yeah, this Phil Levis. I just wanted to respond to Thomas, which is that I agree that having bodies that are doing interop tests, et cetera, would be really valuable. But from my personal experience, that's actually been, as not being someone in the industry, that's actually very difficult. For example, we started this wanting to implement OpenThread. To do that, I had to download a specification document which required me to sign a legal agreement. And it's watermarked to me, right? Because I'm not allowed to share this. Every single person who wants to read it has to download a separate copy. And if you don't think that this isn't pay to play, right? If I actually wanted to do full interoperability tests, the idea that I have to pay to play to do 6LoWPAN in order to interoperate, to me, that it might be that is in fact what we have to do, but it rubs me the wrong way. Maybe that's because I live in. But that's just, this is sort of what sort of prompted this, and this is sort of crazy that I have to sign these kinds of legal agreements just to send IPv6 packets. right?
Yeah. So we have this thing. We'll talk about it tomorrow at 6ish. We have this project called F-Interop, which is a free online interoperability platform. You can send it CoAP and 6-dish and 6LoWPAN packets, and it will tell you whether you're compliant or not. So it's kind of the free version of what you're describing. Thank you.
Thank you. Thank you very much. Yeah. So I think there's maybe further revisions to be done here. So we're out of time. If anybody has the other blue sheet, we have to. Oh, there's the other. Okay. Thank you very much. See you in Bangkok, I guess. Yeah, that's right. I haven't signed. It's on here. You signed there.